Hi, Sriram. Can you hear me? Good morning, Sriram. Can you hear me?
Good morning. Hello. Yes, I can hear.
Yeah. Hi, Jaslyn. Good evening. Can you hear me?
Good evening, sir.
Yeah, I can't hear you clear. Could you
Good
speak up a
evening,
little
sir.
bit, please? How are you? Are you able to hear me?
Yes, sir.
So I'm sharing the screen. Just give me a moment. In today's session, we will look at database and SQL. Okay. Database concepts, introduction to SQL, connecting to database, and so on, which forms a part of the introduction to application development frameworks, because the framework itself, I'm not yet started. These are some prerequisites for the application development framework, which are HTML and SQL. Okay, so that's the session's coverage. Today, we'll just look at SQL. Okay. Uh, so, yeah, before I get into it, any questions, Sriram, from the last sessions? Anything you want to? Uh,
Uh,
you're able to
well,
follow along so far,
yeah, I was able to follow so far. Yes.
and yeah, the last session was HTML, and today, yeah, there are some quizzes along with each lesson. So feel free to go into those quizzes and respond to them. Uh, so there, at the end of each lesson, we got some quiz, which just checks the basic coverage has been understood. Okay, and in terms of HTML, Jocelyn, you have some prior exposure to HTML, I believe, right?
Yes, sir.
Anyway, so some basics is required. So that was covered in last session, and this we'll get into introduction to database and SQL. Okay, so here we have databases is a collection of records. Okay, earlier in a traditional system, you would maintain some registers. Record keeping was like some books kept with certain rows and columns and all that. You will have to probably go sign a register, uh, or maybe like a log. Okay. So whereas that information in a piece of paper or in a register is not permanent. Okay, meaning somebody could tamper, okay, that record, and it could be like some natural calamity could even erase the data or destroy such a record. So the origin of databases is coming from uh, not to have a file-based system, whereas the records in a software can not be tampered so easily. So a collection of records is simply what's a database. It is not a file. It's not a file system. Why? Because files are typically either binary data stored in sort of a document, and either it could be text information, it could be anywhere like Word, Excel, things like that. Okay, so files could either form a particular type of uh, database, like even a comma separated file is a text file, right? So Excel is itself a binary file which has rows and columns. But the problem with that is there are scope of errors, and um, if you do calculations in an Excel, it could be just like uh, error prone. Okay, you could have a formula and it could copy over wrongly and you have error prone. And someone could tamper those files. Okay, so it's still a collection of records in an Excel, but it is having the risk of um, being an error records. Okay, so what a database is simply a collection of records, and the records, what we'll see, especially with origin of SQL and databases like Oracle, we have those records which can have some relationship. Okay, so we'll see the details. Okay, but typically this databases is a logical collection of records. That means it's not a physical record. Physical record in terms of real life is a physical book, like a register and paper, right? Whereas in terms of software, physical records are physical files. Okay, like I have an Excel file or a text file. Those are physical layer of records. Whereas when you say database is a logical collection of records, uh, there is a representation of this information, not at the physical level, it's inside the database. Okay, so inside the database in terms of rows and columns, so records are in rows and columns in a table. Okay, so what is a table, right? The table is inside a database. Okay, and a database is in terms of a logical record, it's having a collection of tables, it's having more than tables. You can have other database objects, so like indexes. So there are several types of logical objects inside the database, which could be like tables, indexes, and so on. Okay, so it's a logical collection of objects inside what's called a schema. Okay, we'll see what a schema is, but the schema is an example of a schema could be like here is a HR system inside which you could have employee records, department records. You could have some other information about various leaves and other systems. So each of that is inside one schema. Entire HR would be having HR related information, employee, department, leaves, and so on. So that collection of logical tables and indexes is inside what's known as a schema. Okay, and a collection of schema, meaning I might have a HR information grouped in one schema. I could have the financial information in another schema. So logically, I could have schemas. All this together form the database. Okay. So when you hear the word database, it has a logical meaning. Meaning it's a logical collection of uh, objects, which could be tables, indexes, and so on. So records are identified inside a table. Okay, the table has rows and columns, much like any table, much like the Excel table, right? It has rows and columns. Records are identified uniquely with a primary key. Okay, now primary key. Okay, primary key is allowing me to uniquely fetch a certain row. Okay, I can fetch the student information with the student roll number. I can fetch my department information from a department number. Okay, so or employee with an employee number. So uniquely identified column of that table is called the primary key. So no two values of that primary key will be the same. If I give employee number 101234 to some employee, the same employee who is having the identifier, which is the employee ID as a primary key, cannot be assigned to another employee. So it uniquely identifies records of the table. Okay, the example I gave is just the student and employee, so on, or department. Anything inside the table has a unique key. that is called the primary key. Okay, and the primary key is uniquely identifies each record. It's one of the columns of the table. Okay, and you can index by any column. Now, index, what is an index? An index inside a table. Take the telephone directory, right? You have every name of the person in some alphabetical order, so that I can directly go to J and call this is Jeslin's name. Okay, and here is Sriram. I have a unique way to go alphabetically sorted indexes. Okay, so this is what an index allows you to do in terms of a telephone directory search. It's a ordered set of organizing that table's information, and the index in database terms is a separate object. Okay, table is one object, index is another object. Table and indexes are part of the database. Okay, and we are talking, these are all logically inside the database. Now, and the index is unique. Okay, unique indexes are the indexes can be also on any column, single column, or a group of columns. Databases, so index is used for searching, basically. Okay, now database has a connection parameter in INI file. So logical level is a database columns and table. Physically, what are they? Physically, yes, there are some physical files, much like you'll have a .xls file or a .csv file. Physically, this database will have one file also. Okay, and the connection to that database, there are connection parameters located in an .ini file. This is an initiation file which the database reads when it starts up. Okay, now who starts the database? Database is managed by what's called a database management system. Okay, a database management system. You might have come across Microsoft Access or some earlier systems like Fox Pro and all that, very old systems. So database management system is a set of background processes which will be responsible for starting the database. When the database is up, these processes are up, and the database management system is going to manage all the logical level operations on this table. It will manage a user querying information. What is a query? User is going to ask, fetch an employee of this employee number 1, 2, 3, 4. Okay, and it fetches. So all such querying operation, write, read, everything. So typically the read, write operations of the database are managed by the database management system. Okay. So typically we have a relational database management system. So database management system can be relational. That means information in one table can be linked to another table. The employee table having all the employee number, employee name, department, and all that can have a relationship with a department table. Okay, so when there are two tables and they're related with each other, related to each other with a common column, we have a structure which forms a relational database management system. So we'll see. And RDBMS, shortly called the Relational Database Management System, has relational records. In a primary key and a foreign key. Okay, so there are kinds of relationship here, one-to-one. One student have one report card. One student can have many, one order can have many order lines. So there is an order, which is the order's header information, which is like, oh, here is the order number, here is a customer number, and then there is order date and all that. And the details of the order like how many items are in that order. Okay, there could be, okay, here is a manufacturer and car. The order could have, I could have purchased some um, a pen, a pencil, and an eraser. Those details are an order detail. So order to order details is one to many. One order can have many items. Okay, in the order detail, many items in the order detail. One to many. Okay, so other ones are manufacturer and car. One manufacturer can have many cars. Okay, so many relationships. The third kind of relations, many to many relations. One student can be enrolled in one course or more. A course can have many students. So this is a one. I'm sorry. This is one way. This is a one to many, and the other way is also one to many. So this is a many to many relationship. Okay. So these are some kinds of relationships between the tables. The information students. There are few students, and courses. Here there are few courses. Each course can have many students. Each student can be in multiple courses. So this is kind of relationships which are there. So primary key is a unique identifier made of one or more columns. Now let me show you some. I said a database schema is a collection of tables. Okay, so here you have a entity relationship diagram, shortly called ER diagram. It means here is a set of entities. Entities are typically going to come in a logical form as tables. Entity is called in design level. It is a diagram. So at design level, these are just by the term is entity and the relationship. So here one supplier supplies goes down here. You see there is something pointing like, so one supplier can supply many items. One customer, okay, can have many orders. Okay, one shipment can have many items. So if you see this way, this is a shipment. It'll have its own columns. This is supplier, it'll have its own columns. Customer will have their own columns, orders. One order can have many products. One product can have many items, or one item can be used in many products. Okay, so you see this crow feet. This is called the crow feet, like the arrow going like that. So if a relationship is like from one entity to another, like a crow feet, that's one to many. And the reverse of it is also true, meaning here one product can have many items. So here is also a crow feet. So these two have a many to many relationship. Such a diagram is called ER diagram, which shows entire relationship. Okay. One item is supplied by many suppliers, right? So it could be one supplier can have supplies many items. So this is also both ways. So this diagram normally is called an ER diagram, and when it is done at the end of the design, each of these form a table, and you have one table which will have a primary key. The supplier, each supplier will be uniquely identified by a primary key column, and that is called the primary key table. And from here, there is a related table called the foreign key table. Okay, and that key would be sitting here multiple times. So one supplier can supplies many items. If he supplies 3 items, each of these items will have the same supplier ID, right? So supplier 10 or that supplier 10 supplies 3 items. And each of these, the supplier number will be 10, 10, 10. So this here 10 can occur only uniquely one time, but in this foreign key table, 10 can occur as many times. So this is called the foreign key table, and that column which repeats, which is unique in the primary key, repeats here in the foreign key many times. This is called the foreign key column. Okay, so that's the kind of relationships. Okay, hope you get that. And what is normalization? Normalization reduces redundancy. I could all have all this information in a single Excel sheet, which has 2 columns for supplier, 3 columns for item. On the same record, I could have customer and the order. The entire thing could look like a big Excel sheet with multiple columns, all in one Excel itself. When that is entirely collected in a single sheet, instead of putting it in relationships, the reason we are having relationships is each of these entities can be managed pretty easily instead of having one master sheet. So when you have that one master sheet with all the columns, which is not separated as simpler tables or simpler entities, that's called a normalized table. Okay, that's called normalized. It is a denormal. So basically, you're collecting everything in one location, and the process of normalization means starting from there to form simpler entities like this. Okay, so normalization, I would have everything in one single Excel sheet. As I separate these relationships, I can make it into smaller entities which are related. Into the whole process of splitting it in or separating it into primary key and foreign key, and identifying the relationship and defining it this way, the whole process allows me to manage it in simpler structure instead of one master structure, right? So that whole process, simplifying it, is called normalization. So normalization reduces the redundancy. Why? Because if I have entire information, one Excel, and each record is going to show everything, column 1, 2, 3 till 40 columns in one sheet, one row having all the values, it's going to repeat information, right? If it's going to repeat for all 3 items, this supplier details, supplier name, supplier number, all of them will repeat. And that, and again, if you see products, if you have 3 products, all this supplier information will repeat. So that repetition is redundancy. Okay, so the whole process of reducing the redundancy is called normalization. Okay, now that's pretty much about the topic at a very high level. Okay, I take a pause here. Anything not clear? Yes, database has physical files, but when there is an RDBMS system, the system has certain processes. When you start that old database. So it could be an Oracle database like this. This is a relational database management system. Oracle is a relational database management system. It's one of the popular database management systems. Other database management system, Microsoft Access, Microsoft SQL, SQL Server, MySQL. There are several databases in the market. You have modern applications, and today companies like Google, Amazon, Facebook have even NoSQL. This is another type of database. Okay, which does not, when basically it's everything is stored in a one unnormalized relationship model Like the one example I told you for the entire Excel having repeated structures. Okay, so that still exists for companies like this, and there are databases such as MongoDB, Apache, Cassandra, Redis. These are available as NoSQL databases. And databases are more scalable and easy to query with, do not involve expensive join operations. So basically, when you separate it into separate tables to fetch information across 2, 3 information, let's say I want to know supplier items and the orders, okay, or I want to know orders, which product and which customer, I have to join these tables by some column, right? This customer ID would be in this order. This order ID will be in this product. Okay, so a product ID could be in this order. Okay, so I have to make joins of these tables and fetch the information. Okay, or query the information. Whole process of fetching the information is called a query or SQL query. Okay, we look at examples. So I have to join and get a meaningful uh, response or meaningful answer to the query. So such joins are required with those normalized database. Whereas if you are not normalizing, if you're having all columns together, these are not required to join. So easy to query with, as they do not involve expensive operations like join. Joining is an expensive operation because when we are talking about these table structures, these are not going to be smaller tables. In reality, when an implementation happens with large customers, you have millions of customers. So there are millions of records, customer records in just one table alone. There are probably several thousands of products and items. There could be millions of shipment lines. So these information can, the amount of storage in these database tables, the records could be large records. A large retail store like J.C. Penney's in the US, they have up to 1 million orders coming every night. So the records which are getting inserted and the huge volumes of the queries which you have to fetch are pretty large. So in such cases, it makes sense to store it separately. And when you have to query some information, you will have to join them with these related columns. The primary key column of one table like order connects um, uh, I mean, the customer could have one or many orders. So the customer ID of one table here connects to the order table, which is the foreign key in the other orders table. So you have to make joins. So when you make joins, think of it like this is a million record table, and this is again a very large thousands of records table. The supplier, probably there are 3,000 plus suppliers, and there are about millions of shipment lines. So when we join these things, it is an expensive query operation. Okay, to fetch joining the record. So that's what they mean by this NoSQL databases do not involve expensive operations like join. Okay, mostly with modern applications. Like this is one example is MongoDB. It is quite popular. NoSQL database. So when you see NoSQL, what is? It's an unnormalized relational model. Everything is in one screen. Okay, so that's still gaining popularity over the web. Okay, due to these companies following them, whereas the traditional enterprise applications like Oracle, Microsoft, handling financial systems or ERP or a CRM system, they all run on relational model. Okay, entity relationship model as a normalized data structures. Okay, the whole process of simplifying into separate entities is called normalization. Why? We are reducing redundancies. Okay, when redundancy means I don't have to store that information again and again each record. When you store such large information, you are taking essentially a lot of space in the database. And if you're looking at millions of shipments, the supplier information could be just repeating. Okay, if you're having several 50,000 products, all the products, the customer information could be repeating. Okay, or order information could be repeating, which is not required. So that's the reason the order is in one table, products is in another table. Okay, so we are having this normalization at multiple levels also. First normal form, second normal, third normal, and then finally arriving at this structure from the original unnormalized form. Okay, so that's about the design, and this is called ER diagram. Okay, this is from the software design standpoint. From the logical standpoint, it's all tables and records as rows and columns in table. Okay, so there is a database management system. There is also a relational database management system. In pure database management system, it need not have any relationship. Okay, each of that information is stored separate. A DBMS. These are typically older systems. Okay, so relational database management system, they are tables related to each other, and they have primary key and foreign key relationship, which is also called a referential integrity constraint. Why? Because it's a constraint. We are constraining to have a relationship between two tables, like primary key of one is foreign key is in the other. Okay, the foreign key is the primary key of another table, which is referenced in the current table. It's the key to establish a relationship between two tables through the RDBMS. This rule which we impose is called referential integrity constraint. Okay, the primary key is a unique key. Okay, primary contains more than one column. Yes, it may contain, but typically one column is a primary key. There could be a combination of column, which is a composite key as well. Okay, so these are quite a very conceptual level understanding of what a database is. Okay, now PostgreSQL. There is typically a large enterprise database, and for a long time, large organizations were only the ones who were running the show in terms of being a software vendor for the database product. Okay, typically Oracle, Microsoft, and so on. But over a span of from 2005 or so, open source systems, right, started becoming popular. And here is PostgreSQL is an open source database. That means anybody can use it freely. There are several such open source databases today. Okay, one of them is Postgres, and it's quite a popular one, going by the symbol of an elephant. It's got SQL. It follows SQL, structured query language, okay, format. And this is an administrator screen. The database is administered by an administrator, and this is the administrator login here. What he logs into, he'll be able to browse. Here are so many servers. Here is databases. It's a Postgres database. Inside there are some database objects. Okay, schemas. You have other database objects inside a database. Okay, table space, the logical separation of the database. Okay, so this is a Postgres database. Now, what is that you'll be required to learn here is you have now a conceptual understanding of the database. There are standards which are formed to the language in which you will interact with the database is SQL, and the standard as well. SQL is also the standard. Okay. So the language you will interact with is called SQL, or structured query language, and it uses some statements like this to create the logical objects like databases, tables, and so on. So here, this is a statement which has create database. So it has some create um, keywords. Okay, whenever you want to create some logical object, you are going to use the keyword create in SQL. Create, what are you creating? A database. What is it? A supplier. The name of this database supplier. So create database supplier. Semicolon is at the end of the statement, and then you enter. It will create a database. Okay, like that. Once you create a database, you can connect to that database like this. Now here we're talking about Python. PG2. This is Postgres connecting to the database using Python language. So Python package like num2 words and so on. This is PG. You use this dot connect function, a method inside that, and you give the name of the database, and these are parameters. So then what happens, it will connect to this database, and the user, when a database is to be connected, it has users, and users from some super users and all that. So there's a super user who's an administrator, whereas here in this case that administrator is Postgres, and the password is like that. So it connects and gives the return object as a connection object. Okay, so here is how you can do the same thing. Host is an IP. This is local host. Database is equal to that, and this is a password. So this is how you can connect, just for information. Okay. Now I told earlier that database has some initialization parameters. So when the database is to be started up, the RDBMS is a set of programs. Okay, see, the database here represents physically represents some files, and logically it is going to be database schema under which database objects are there. So database and the RDBMS, they are two separate. RDBMS stands for the Relational Database Management System set of processes. Okay, so when a database administrator starts, the database.ini file is read, and what it contains is the name of the database, the username of the super user, and host is a machine in which, or the local host or an IP address where the database is located, port, and all that. So when the database started, the RDBMS starts to manage that database. So when you have to physically, you have to give administrator has to start the database. Okay, so when he starts, so he will when it starts, so this database ini file will be read, and it will start that database. Okay, it will start the database. Rather, we are saying the RDBMS is up and the database is up and running. Okay, all the background processes to manage the database, there are several management processes which are, they all are active. So memory will be allocated for the database. Okay, why memory? Because we have to make some large updates. They have to take the information, put it some RAM information. Okay, so that's a database cache, memory allocation. Okay, so much so about databases. Structured query language. Okay, here in this section, okay, take a short pause here. Are you able to follow along so far? Is it too, I've kept it like not too high level? Are you able to follow along, understand any
Yes.
queries, anything?
Yeah.
Okay. Ghislaine?
Understood.
It's conceptual understanding of the database. Okay. So hope you are able to follow along, right?
Yes, sir.
Okay. So a query is a question you ask the database. A query is a question you ask the database, and it's asked in this language called SQL. Okay, so there is a language. So there are some statements and some keywords and some object names and so on. Okay, some syntaxes are there. There's nothing more to it. Okay, so any language, okay, in this case, the relationship SQL language uh, is used by the RDBMS, is used by the Relational Database Management System, typically Oracle. Okay, SQL has a syntax, and SQL is based on ANSI and ISO standards. So SQL itself is standard in the database domain, and it's an industry standard. It complies to ANSI and ISO standards. So these are some open standards. ANSI standing for American National Standards Institution or something. ISO is International Organization of Standardization. This is American, this is European. Okay. Now, to access, okay, before we have to start doing SQL, you have certain operations, typically known as the CRUD operations, basic CRUD operations. You will come across this create, read, update, delete. Okay. So if you take employee information, you'll have to create the employee table. Of course, then you'll have to go insert records into it. So this create, the create in the CRUD refers to creating records, and prior to creating records, the table itself has to be created. Okay, that's something. So CRUD, create. Read is your querying information. It's a SQL query. You'll fetch information with reads, so also called query. Update, you might have to change information, modify information. Delete, you're going to remove information. And this deletes are all logically removing rows from table inside the data. So this CRUD operation is a typical term used when you build some application. Okay, when you build, let's say you're building a student information system, CRUD operations will be like on the student record. Okay, there could be a HR information system. CRUD operations could be on the employee record. Employee records will be created. Employee records will be read. Employees might have some change in employee information, like department change. You might have to update that information, and like delete records, delete rows, delete very negligible, but typically it does occur. Okay, you might have to get rid of some records. That's typically a delete. So CRUD operations is what it is called. Even so in SQL, you have, when you have to get to create, let's say you created the database. Now the database is ready to accept certain other objects inside the schemas, right? Typically, create a table allows you to create a table. It's a statement, allows you to create table. Here, create table students. Okay, and out here is the syntax. Okay, so create table students, and within brackets, I have to define the columns like this: ID, integer, primary key, comma, name, a data type, not null. That means this name cannot be left blank. Yeah. Student name is required, so student name is defined as a text, not null. Text or a string, not null. Okay, character. Okay, gender can be a character information or text information, not null. Gender cannot be left blank. Each column definition is separated by a comma. And then this inside the brackets, inside parentheses, and semicolon here is at the end of every SQL statement. At the end of every SQL statement, it's a semicolon. Once I create the table, you can select query from the table. So, but we have just created the table, there are no rows there. So I will insert one student, insert into table name, the student's table values. So the pink ones are in keywords. Okay, values within bracket 1, that's a student roll number, comma, name, ran, comma, gender, male. Okay, and then I go on to create another record, Joanna, female. Now once I have inserted 2 rows, I am going to fetch star from students where gender equal female. So it's going to fetch Joanna's record and show it back to me. So this select statement is a query. Okay, it's a SQL query. So a SQL query uses a select statement query data from a table. Star, what does that symbol represent? It represents all the columns. I've got 3 columns here. Instead, I could fetch each column separately by the column name, or I could have an asterisk or a star here, typically called star, select star. From is a keyword, from followed by a table name. Okay, where is a criteria, a filter. Filter what? Gender equal to female. So then only Joanna's record will come. Okay, if I just say select star from student, both the records will be no criteria, no where clause. Where clause is this where followed by a column equal to value. Okay, this is a condition. Okay, it's a condition. So that is the simple SQL statement to create tables, define the columns, insert 2 records, and select from the query. Okay, we have other types of columns. We have actually created some simple columns here, ID, name, gender. We do have so many of them. Character with certain 50, varchar 2, variable address lines could be different length. Okay, text, some department, boolean, true and false, integer like numbers, floats are there, decimal, double, date formats are there, dd. Okay, so this is typically what is a SQL columns data type definition, not a problem. There are many data types. So here is create table persons, ID, int, not null, last name, first name, age. I go on to define my own constraint. What is the constraint here? A primary key. I'm putting this ID and the last name together is my primary key. 2 columns define. Star, select star from customers where country equal to Mexico. It will fetch only customers from which match this criteria where we country equal to Mexico. You could fetch individual columns or you could fetch aggregate of columns. Min and max are functions which can be used in the select. This select follows some column names. We may not have star all the time. We could choose to have specific columns, maybe 2-3 columns. I could group by, let's say, a column name, group by country. Okay, how many customers are from this country? When I say group by, it will group by the columns which I fetch, and it could, when you group by the column, I could have aggregate functions. Count. Okay, count star. So from Mexico, I have 150 customers. So country, comma, count star means it will group by country 1, Mexico, count star 150, means 150 rows who are customers from Mexico. So when I group by, I can use these aggregate functions. All these are aggregate functions, minimum, maximum, average, sum, count. Like what we'll do now is we'll just jump into a quick hands-on. Okay, we'll take a short break. Is that fine? Sriram, would you want to
Yes.
have a break or you want to end till 11:30 your time?
You have to leave 15 minutes. So
We will continue, right?
sure.
I will give you a break in about 10 minutes. Is it okay? Or
Yeah,
we'll
it's fine.
wrap it up in 10 minutes.
Okay. Yes.
Now, quite simple. Let me run through this hands-on. You'll create a department table. You'll create an employee table. We'll insert 4 rows into department table. Select all the rows of the department table. Insert rows into employee table all at once. Query all information from employee table. Run that SQL query. Joining employee and department table to create a meaningful records. Run a SQL query to show counts of employees in each department. I have sales department, which will have 10 records. I have other departments, each number of records. Okay. So likewise, here is an example right here. The records, as you can see, this is a department: accounting, research, sales. These are department numbers and they're located. Okay. This is the department table. In the department table, department number is a primary key, uniquely identifying each department. Okay, that means sales will not have another repetition with 30 is only one time. Okay, that's 30 is unique. Okay, if it is another 30 cannot be a duplicate in this column. So that's the primary key. The primary key cannot have duplicate values. The employee has employee number, which is unique, right? No two employees should have the same employee number. So that's unique. So this is primary key. Employee number is a primary key of employee table. However, the department number is repeating. So that means I have in accounting department, I have 10, the president, another 10. So you can see it is repeating. It's duplicates here. 20, 20, 20, 30, 30, 30, like that. So this is a foreign key. The department number of employee table is related to the primary key table department number. Okay, so that relationship is what it is. And we have other columns, what you can see. Okay, employee name, job, manager of that employee, salary, commission, so on. Never mind. So here, when we join the employees tables department number with the department tables department number, you can pick both the columns. The column of employee name is from the employee table. Department name is from the department table. So I can put it next to each other. So I'm joining. So such a join is called equi-join. Okay. So why to produce all this in one row? Okay, so this is what we are saying. Denormalized structures, we need to join to fetch columns from both the tables. Now here, location is from department table. Employee is from employee table. Job, employee number, hire date are all from employee table. So if we join, it shows some meaningful information like that. James, sales, works in sales department, his job is clerk, and his employee number is that. His department of sales is located in Chicago. Or same out here. Martin, Chicago. Okay. So this is equi-join. Okay. Then count, I said aggregate functions like count, max, min, average, all this can be included. So sales, there are 6 employees. Research, there are 5 employees. Accounting, there are 3 employees. Okay. How? I'm grouping by this column. So when I group by department name, this group by column occurs uniquely once, and on that grouped column name, by that group column name, you can count. Okay, so this is an aggregate function. Why? Because this will be select department name, comma, count star. And the next line will be group by department name. So that will produce such a result. So here multiple people of this sales department, it will count. Pick one occurrence. Pick one occurrence. So here sales 1, 2, 3, 4, right? You'll pick one occurrence and put it in does the count. Total 6. Research like that. Accounting 3, so on. Is this clear? So this is a count function on number of employees. So what we'll do quite quickly, here is one link here. I'll just pass this link. Hold on. On your browser, I will paste this link on the chat. You can go to this. Put it on the Zoom chat. So onto your browser. Yeah, just right click on this link and open the link. Okay, you typically don't have to spend a lot of money to buy a database and run SQL. This is an open extend class, extensclass.com SQLite browser. It's much like the interactive Python. This is interactive SQL, okay? Meaning it gives you a readily available SQLite browser, which is temporary, okay? And you can try out some database operations here. So as soon as you get in here, you could have this queries, sorry, you zoom out a bit. Yeah, you could, it gives you a temporary database, okay? And you can readily run, click on this run to run your SQLs. You can run your queries like that. All of you here in this page.
Yes.
Okay, it lets you save, but it will not stay. Data will be sensitive data, it will be removed, okay? So it doesn't let you save, okay? So and it like so here you can run your select, update, delete, insert operations. You could create your own table as well. The tables created will appear under this table node. Views are some other queries of the database. So I have this SQL here, which is readily coming there. See, these are some select from, these are in capital case, the names are in lowercase, order by. Okay, these are supposed to be also in capital case, like this. Okay, and when it's ready to run this query, I could run by clicking this run button. So you could create tables and run, okay, and this result will show up here. So what we're going to do when we connect to this database, I think okay, this okay, what we'll do is we'll continue this in the next session. Okay. I think Sriram, Do you have some more time? I think, yeah, you do have some time, right? So let's get in here. So select documentation is here. Okay, there are no tables at the moment. So, but this wheel, are you able to follow along? Hope you are able to follow along. Wheel will allow you to execute whatever is here. I'll just zoom out a bit if it's a little overwhelming. Zoom out a bit. Okay. Okay. So here in this, we can say create table. Okay. TPT like that. You can follow along with me. So just type as I type. PTNO. Okay. So this exercise here, create the department table. Okay. This way, department number, name, location. Now I agree you may not have all these scripts here, but let's do one thing. I will create a sample table and you follow along. Okay. Department number. Okay. I just put in number. Okay. D name will be a character of 100. Okay. Or that's a 150 characters, the name. Okay. Like that, the comma is there. And what is the other one? Department name, location. Okay. So LOCATION or LOC is enough. Location, where char to variable character of 100. And then it's over like in semicolon. Now this is a create table statement. I want to run this. I just run. So it just gives query as no result, but if you just run this here, it refreshes and see this department table has got created. This department table just got created. If you have to click on this wheel, it will refresh. And then I can insert two rows, insert into DPT values 10. Okay, 10 was accounting. So this is a string. I put it in quotes. Yeah, like that. Okay. So this will allow me to insert one record. But when I already have created this create table, I will have to comment this. Okay. So for now, I just remove that and then run. If I refresh, I can select star from department table. After inserting, I could insert multiple rows. Sorry. I could insert multiple rows. So let me do one thing. I insert one more row here, 20. And this is research and Chicago. Okay, like that. And each of this is separated, starts from the beginning like that. Okay. So I have a bunch of these statements and run. Like, okay, insert as an error now because it's already semicolon, either semicolon or a slash. Either it could have a semicolon typically. That should be fine. Syntax is equal. Okay, 5 rows inserted. It just inserted, you see, 10, 10, 10. I did not have any primary key, so it inserted so many times accounting. Okay. When I run every time, it is just going to insert these things. So see, 7 rows like that. So interactively, you can do all these things, and you refresh, this table is there. And refresh, sorry, I refresh, I click, and all these records are there. Okay, so this one, interactive SQL. Okay, sorry, I'm not able to close this here right away. Yeah, here. So you can try these SQL statements. We will do this in the next class. Okay, so I just introduce you to this with some scripts. Right. Okay. So what we'll do is, I do have the scripts since Shriram has asked for a time. Let's wrap the session here. We'll continue with this interactive class in the next session. Okay. You we can meet tomorrow at 9 Eastern, 6:30. But look out for my message. Sometimes there will be an hour delay possible. Okay. Is that fine, Sriram?
Yes, yes.
Okay. So we will continue from here. Jocelyn, are you able to follow along this session?
Yes.
Okay. So tomorrow we'll continue with the scripts. I do have the scripts here, and we will wrap the session up. Okay. Okay then. Thank you. Take care. Bye-bye. Bye-bye.
Thank you,
Okay.
sir.